Hey guys, for this video what we're going to do is we're going to use synthetic division to divide two polynomials. It's called synthetic division because it synthesizes long division without actually doing the long division. In long division, remember that we usually multiply and then subtract, multiply, subtract over and over again. So to synthesize that, what we're going to do is we always want to take this value here. Let me grab another color. We're going to take this value here, and we're going to do the opposite of this because normally we subtract this value, so when we subtract it changes the sign, so we're going to go ahead and change the sign of this. And synthetic division works best if you have a 1 in front of x. Later I will do a video that shows you how to do this when there is a value in front. But for some people, they don't like it. They would rather just use long division because of the fact that there could be a number because you're going to have to deal with fractions. So the other thing that you need to check to make sure is that the degree of your exponents goes down in order of exponents. So it goes down 3, 2, 1, and then 0 exponents, which this one does. If you are missing a term, whether you're doing synthetic division or long division, you do have to put a 0 with that missing term. So since this goes down 3, 2, 1 with the exponents, we're okay. What we're going to do is we're going to take the numbers in front. So the coefficient of this one is understood to be 1. The coefficient of the next one is also understood to be 1. Then we would have -4 and +9. So we just write our coefficients here. So this is just the coefficients. Okay, and then what we do is we always bring down, our first step is to always bring down this first number right here. So we bring down our first number, and then we just simply multiply and add over and over again. So I'm going to take this value here, multiply it by this value here. So I'm going to do 4 times 1, and I'm going to put the answer inside of the box. Okay, then we always add the column, and the reason we add is because we already changed the sign, and subtraction really is just adding the opposite. So because we changed the sign of this, we're just adding the opposite, which is the same thing as subtraction. So if I add 1 plus 4, I get 5. And then I would multiply 4 times 5, so I would take this number again on the outside and multiply it by the number down here and put the answer up here. So 4 times 5 is 20, add, and 16. If I was trying to find the zeros, if I noticed that these numbers were getting so large, I would probably stop with this one being a factor. I already know that this one's not a factor because the last number 9 is not divisible by 4. But sometimes you may be looking for the zeros and doing this over and over again. In this case, we're not. We're just simply dividing. So then I would do 4 times 16, which is 64. And add the last two. 9 plus 64 gives me 73. This last part right here is always going to be the remainder. So this one is not a factor because it has a remainder of 73. So as far as writing the answer goes, remember that we started dividing an x cubed by a linear term, so that means we're going to go down by 1 degree. So these right here are going to be the coefficients of the answer. And we always go down by 1 degree to start with. So I started with x cubed, I divided out an x, so my answer would be x squared. And I really have the 1 there, I just don't write it, plus 5x plus 16. And then you can either write it as remainder 73, so depending upon the course that you're in some courses this is completely acceptable. In some courses, you do have to write it as a fraction, so you could also write this as x squared plus 5x plus 16 plus 73 divided by x minus 4. So you can always write it like this if you would rather. Some courses, especially if you're working like in a Pearson program like my math lab, a lot of times they ask you for the quotient. This part right here is the quotient. And then this part right here would be the remainder. So that's what you would put in for the remainder is the 73. So a lot of it just depends upon what program you're working in, what level of math you're in, how you would write the answer. As always, thanks for watching. If you have any questions, please let me know. If there are other topics you need me to cover, please let me know that as well.